So एक electronic configuration में there was a thing called two special cases. ठीक है, वो हमने पढ़ लिया था कि how many different ways can we write the electronic configurations. अच्छा, one thing is कि अच्छा, एक तो group wise I'll just add कि uh, when you have transition metals, ठीक है, we did so we're going to do two special cases which are so these two special cases are chromium and copper. The reason I'm calling them two special cases is that their electronic configuration is slightly different than what you get from the Aufbau principle. For example, if you look at copper, if you follow the Aufbau principle, copper is 29 electrons. So that means it's 1s2, 2s2, 2p6. Then you've got 3s2, 3p6. Then you have 4s2, and then you have 3d9. That is what you're going to get if you follow the Aufbau principle. और उसके अंदर ना end के अंदर what you're going to do is you're going to switch the positions of these two. ठीक है, so and 4s2. So change the positions of whatever you have at the end. Usko order mein, third shell and then fourth shell on the outside. Anyways, so for copper, remember this. This is what you get from the Aufbau principle. But this is not copper's electronic configuration. Uska jo end hai na, it's actually 3d10, and the actual electronic configuration is 3d10 and 4s1. So it's not exactly following the Aufbau principle. Okay, so make sure do this correction. Okay, or remember this. So it does not follow Aufbau exactly. So Aufbau exactly. ठीक है, बिल्कुल exactly follow नहीं करेगा. And then there's chromium as well. ठीक है, that also does not. Although these are not the only elements that Aufbau principle ये था ना कि the electrons have to be filled in this order, that you're going to have 1s, then 2s, then 2p, then 3s, then 3p, 4s, 3d, right? But some elements will not follow that exactly, and copper is one of them. Okay, so you got to remember copper's case. And then you've got chromium as well. That's also important. Chromium ke andar na, you've got 24 electrons. So instead, so the electronic configuration is going to be 1s2, 2s2. So you're going to have 2p6, and then you have 3s2 and 3p6. And you'll have 3d 3d से पहले 4s fill होता है. So you'll have 4s, and then you'll have 3d4. ठीक है, after writing the electronic configuration, I'm just going to correct the order, which is इसको उठा के इधर कर देते हैं. 3d4 has to be on this side, and you got 4s2. अच्छा, anyways, for this as well, remember it's not exactly following the Aufbau principle. It's actually 3d5. Instead of 3d4, it's actually 3d5. Or 4s, that's actually 1. Okay, the number of explanations for that, none of them is actually sufficient. It's just that this is what the electronic configuration is. Okay, you just have to remember this. Okay, clear? In the akhir end mein na, you have to remember this. Is that clear?
Yes, sir.
I guess we're done with the electronic configuration. I'll just ek mein end mein I'll just draw a pure table, which is so it just tells you this is what the pure table looks like. You got this is approximately how the pure table looks like. Group 1, 2, then you've got transition metals. Actually, these ones over here are S block elements. They're known as S block. The ones in the middle, they're known as, based on the electronic configuration, they're known as D block. And the ones on the extreme right, these are known as your p block. Okay, these ones are known as p block elements. And the reason I'm talking about this is we've already did this. The reason you call them p block and d block and s block elements is that the last electron actually goes into an s. This one, the last electron goes into a d. This one, the last electron goes into a p. ये हमने किया भी था कि if you have a group 7, right? So group 7 will always end up with P5. Group 6 will always end up with P4. So group 13 to 18, these are called P block elements. All their last electron actually goes into a P. वो जो पहले दो groups हैं ना, they're your S block elements. And if you have a transition metal, then the transition metal would always, where's the transition metal? उसके अंदर the last electron is actually always going into a D. ठीक है, so that's what a transition metal block is. ये clear है? ये बात भी clear है?
जी सर।
अच्छा, आप बस वो पास पेपर्स करते हैं इसके, ठीक है? सो लेट्स किधर है पास पेपर्स नाउ? अच्छा, एटॉमिक स्ट्रक्चर के सब टॉपिक वाइज इसे कॉपी एक बना लो एक सेकंड, so that we have the answers as well. Just one second. Share this one. So we're going to start with the first of the basic questions. Okay, so we're just going to go over them quickly. As a subtopic wise, let's start with just proton, neutron, electrons. Okay, the first initial questions. Pretty sure they're very easy. levels की तरह. You just have to figure out. For example, the first one, neutrons are passed through an electric field. The mass of one neutron is relative to 1/12 the mass of carbon-12, and any deflection in the electric field is recorded. So mass of neutron is relative mass is 1, and it's obviously not. So this one is obviously not deflected, right? सबको clear होगा. In which pair do both atoms contain the same number of neutrons? That's very basic as well. The same number of neutrons, 14, probably. Probably, okay, you have to write the proton number, that's 3. This one is, beryllium is 4. Boron is 5 and carbon is 6. So I think it's this one. Okay, it's going to be A. Same, they've got the same neutrons. Bas periodic table kholo, find out the proton number. We've got this one. Is saying that this thing is an isotope, is mentally useful, and it undergoes a natural radioactive process to give an isotope of a different element. The GE is, he's saying it's 68. And do we have a periodic table? We have a periodic table. So 68, I guess, is periodic table. Achha, so GE is 68. Germanium, that's so uska jo proton number hai, that's 32, right? I said, remember this number changes. You have isotopes, right? So he's talking about a radioactive isotope, which is 68. The proton number for germanium is always fixed. It's 32 given over here. So if it's 32, right? और वो कह रहे कि it changes, it undergoes radioactive process to give an isotope of a different element where it's X and it's 68. And this transformation of G occurs when an electron enters the nucleus and changes a proton into a neutron. So this is what happens. He's saying that a proton, what does it do? It changes to a it changes to a neutron, right? This is what he clearly stated, that the transformation of germanium when an electron enters the nucleus and changes a proton into a neutron. So a proton changes into a neutron. So germanium ka pehle kar lete hain. How many protons it's got? It's got 32 protons, and it's got how many neutrons, right? It's got 36. 36? What's 68 minus 32? That's 36 neutrons, right? So he said that a proton changes to a neutron. So this X will have 31 protons, and the proton changes to a neutron, so it's going to be 37 neutrons. Isliye you're getting the same atomic mass, nucleon number. That's 31 plus 37 still gives you 68. अब ये आपके पास, which statement about the composition of this is correct? It has 4 electrons in its outer shell. अच्छा ये clear है? ये बात यहाँ तक clear है? Is this clear? काफी clear है? Ahmed?
Yes, sir.
Achha, now the thing is, now he's asking, achha, so the proton number will be 31 for X. Okay, that's going to be the proton number, right? Now he's asking which statement about the composition of an atom is correct. It has 4 electrons in its outer p orbital. So first thing, it's 31, right? How do you identify the position of an element in the periodic table? You open the periodic table, 31 pe jaake dekho. What do you get at 31? 31, you have gallium basically. So we're dealing with gallium. Gallium is group 3. What is the electronic configuration of group 13? Group 13's electronic configuration. But 31 se humne idea laga liya कि it's in group 13, right? And we know कि अभी हमने किया था group 13 electronic configuration is S2P1, right? Any element in group 13 is going to be S2 and P1. So the first statement is definitely incorrect. It has 4 electrons in its outer p orbital. That's wrong. It just has 1. ये clear है? ये बात clear है?
Sir.
अच्छा, फिर it's got 13 electrons in its outer shell. No, it doesn't. It's got 3 electrons. Group 13, it's got 3 electrons, right? So that one is wrong. It has 37 neutrons. Yep, that's correct. 37 wala neutrons wali baat, that is correct. Okay. So this, I mean, so remember, it's a basic question. But they're going to ask you if they give you a difficult. I mean, they can give you a difficult question where they can make it very, very tricky as well. Okay. अच्छा, अब ये कि sodium azide is an explosive used to whatever it does. What are the number of electrons in the sodium ion and the azide ion? So sodium ion में electrons and azide ion. So you got Na and N3. Asa, can you tell me the charge on the azide ion? What is the azide ion? I mean, we know that this is the sodium ion, right? So azide ion is going to be this other one, right? It's sodium azide. So azide is going to be N3. What will be the charge on this N3? It's going to be -1, right? Is that clear? Na is +1, N3 is -1. Clear? Acha, ab ye ke sodium ion electrons. Sodium is 11, right? But it's +1, so it's got 10 electrons, right? So it clearly has 10 electrons. Now N3, how many electrons does 1N have? It's got 7 electrons. You got 3N, so that's 7 electrons plus 7 electrons. So that's a total of 14 electrons. 777, that's 21 electrons, right? So that's 21 electrons plus it's got a negative charge on it. So that means there's 1 extra electron as well. So the total number of electrons is going to be 22. So the answer is B. Ye clear?
Yes, sir.
अच्छा, अब ये कि the relative MR of a particular sample of chlorine is 72. Which property of the atom in the sample will be the same for all the atoms? The relative MR of a particular sample of chlorine is 72. I mean, chlorine is Cl2, right? Okay, chlorine is 72. So which property of the atoms in the sample will be the same for all the atoms? So remember, I said, does anyone know how many isotopes does chlorine have? We didn't do isotopes, but we didn't do we didn't do mass spectroscopy, but is any general knowledge है कि chlorine के isotopes कौन से होते हैं?
Is it two?
I said remember chlorine in the chlorine का जो वो है ना, it's where's chlorine? It's 35.5, right? Actually, there is no chlorine 35.5. There's chlorine has a lot of isotopes. ठीक है, so Google कर लेते हैं, ठीक है? There are two main isotopes. One is 35, the other one is 37. Two neutrons, kind of, there's a difference of two neutrons. So Wikipedia, the isotopes of chlorine. हाँ ये. अच्छा, एक atom के ना बहुत सारे isotopes होते हैं, but some of them are abundant. So you can have a look. Chlorine, I mean, there's chlorine 28 as well. ठीक है. इसमें ना वो भी दिया होगा abundance. So this is almost non-existent. Chlorine 34, right? Chlorine 34 is almost non-existent. I mean, it does exist, maybe a few atoms on planet Earth, but very, very rare. As for chlorine 35, look at chlorine 35. It's uski abundance here, that's approximately 75%. 0.75 out of 1, right? It's 75%. And then there's chlorine 37. Chlorine 37 is approximately 25%. Okay? So basically, the element chlorine is actually made up of two isotopes. Baki sare almost non-existent. You even have chlorine 52 as well. Okay, you've got chlorine 52. Uski half-life dekho. Look at the half-life. It's in nanoseconds. Yani ye banega ekdam se gayab ho jayega. It's just going to decay very rapidly. It's going to happen so quickly. Like most of these isotopes, the reason they don't exist is कि कुछ second के अंदर ही तो गायब हो जाएंगे. Like Cl42, it dissipates or decays in 6.8 seconds, right? तो इनकी लेकिन ये stable है. Chlorine 35, that's stable. Doesn't really decay. ठीक है, just maintains its state. अच्छा, anyways, वैसे हम time ज़ाया कर रहे थे इसमें. What is important is chlorine has two isotopes. One is Cl35 and the other one is Cl37. ठीक है, हम आगे जाकर ना डिटेल में पढ़ेंगे when we do mass spectroscopy. Right now we haven't done that. अच्छा, now if the chlorine molecule has a mass of 72, what does that mean? If the chlorine molecule has a mass of 72, तो इसमें कौन से वाले chlorine पड़े हुए? Are both of them 35 or both of them 37 or one of them is 35 and the other one is 37? क्या होगा?
One is 35, one is 37.
ठीक है, so the only way you can get 72 is that you have both isotopes. One is 35 and one of them is 37. They're bonded together. अच्छा, so nucleons दोनों में different होगा. So which property of the atoms in this sample will be the same? The nucleon number will obviously be different because one is 35, the other one is 37. The isotopic mass is also going to be different. One is going to be heavy, the other one is going to be light. Radius जो होगा ना वो सारों का एक ही होगा क्योंकि they have exactly the same electronic configuration. 17 electrons. This one will also have 17 electrons. Okay, they'll have the same outer electronic configuration. They'll have the same chemical properties. Mass different hogi. Okay, you be clear that the answer to this one is 1. Only the radius. Okay. Achha, this one, Y3 minus 1 contains. Achha, remember these questions are kind of like really basic. लेकिन वो देखा होगा level थोड़ा सा ना O levels के मुकाबले में it's slightly higher now. ठीक है, so Y3 minus 1. Y3 minus 1, it contains 18 electrons, right? That's what the question states. And it has a mass number of 31. So 31 is the mass number, right? How many protons and neutrons does Y3 minus 1 contain? First thing, an atom of Y, how many electrons will that have? Well, its original electrons. Okay, it's going to be 15, right? क्योंकि 18 तो 3 गेन करने के बाद आया ना, तो that means originally it had 15. So originally the proton number was 15, right? And if you calculate the difference, that's 16. So it's going to be A. Clear है?
Yes.
अच्छा, फिर ये वाला कर लेते हैं कि the number of protons, neutrons, electrons are all different. किसके अंदर? Which one? This one is not 16. I mean, this one is 16 protons, 16 neutrons, right? तो ये तो different नहीं है. This one is 15. It's neutral, so it's 15 protons and 15 electrons. It's obviously not different. It's different. It's 10 electrons and 11 protons and I guess 12 neutrons, right? So it's going to be B for this one. Achha, this one. Now this one is an interesting question. ये वाला क्या question है? Okay, beams of charged particles are deflected by an electric field in identical conditions. The angle of deflection of a particle is proportional to its charge to mass ratio. Achha, so what is happening is you got an electric field. So let's say you got a positive plate on top and you have a negative plate at the bottom. Or what's it? So you got a positive plate and you got a negative plate. In an experiment, protons are deflected by an angle of 15 degrees. So imagine protons are flying between these plates. So imagine protons are moving between the plates and they're deflected by an angle of 15 degrees. कहाँ पे होगा? नीचे की तरफ. ठीक है, so they get deflected by an angle of, मतलब वैसे उन्होंने कहाँ जाना था? They were supposed to go straight, right? So but right now they're making an angle of 15 degrees. Is that clear?
Yes.
So what did he say? He said that the deflection of a particle depends on its charge to mass ratio. That makes sense. Okay, deflection is proportional to charge over mass. You get heavier particle hoga, so it's not going to get deflected that much. It's going to be inversely proportional. Greater charge, it's going to be more deflected, right? So that makes perfect sense. Proton ka charge to mass ratio kya aa raha hai? That's for proton the charge to mass ratio is 1:1, right? It's got a +1 charge. It's got a mass of 1, right? अच्छा, अब वो ये कह रहे हैं कि there's another experiment. Under identical conditions, there's a particle y and it's deflected by an angle of -5 degrees. So there's some other particle, which we don't know what that is, but it got deflected at an angle of -5 degrees. So that means it must be going in the other direction. Okay, proton 15 degrees, it's going in the -5 degree direction, right? So the question is, what is y? I mean, that's basically the question, ठीक है? तो अब पहले तो मुझे बताओ कि the amount of deflection. For a proton, the charge to mass ratio was 1/1, right? Remember, the deflection depends on the charge to mass ratio. Look at the deflection of y. The deflection of y is 3 times lesser. तो उसका क्या मतलब है? What is the charge to mass ratio of y? Deflection देखो, वो 5 degree है, ये 15 degree है, so 3 times less. And deflection is proportional to charge to mass ratio. So the deflection is 3 times less, right? But the deflection is 3 times less, right? So that means the charge to mass ratio would also be 3 times less, right? But ये बात समझ आइए कि proton के comparison में the deflection is 3 times less. So if the deflection is 3 times less, the charge to mass ratio would also be 3 times less. तो इसका मतलब है y का जो charge to mass ratio है would come out to be 1/3. It's not going to be 1/1. It's going to come out to be 1/3. Does that make sense?
जी सर.
ये अगर 1/1 था, this would be 1/3. Why? Because deflection or the angle of deflection is proportional to charge to mass ratio. Deflection, if it decreases 3 times, so the charge to mass ratio would also be less by 3 times, right? वहां पे 1/1 था, तो यहाँ पे 1/3 होगा. बाकियों को क्लियर है सारों को?
Yes.
अच्छा, मुझे बताओ कि अच्छा प्लस एक तो 1/3 यानी चार्ज टू मास रेशियो प्लस what would be the charge on y? Plus होगा, minus होगा? Is it going to be a positive part? It's going to be minus, right? Because it's going in the other direction, right? So uska charge bhi opposite hoga. So let's start with the first one, charge to mass ratio. Particle number one, option number one. क्या mass है इसकी? Particle number one. What is the mass of this thing?
3.
It is 3 because remember electron doesn't really have a mass, right? It's so the mass is 3. What is the charge on this thing?
-1.
It's going to be -1, right? It's got 1 extra electron. So -1/3, वो ठीक है, वो 1/1 था, the -1/3. So that means the first particle will have a deflection. It will exactly, because the charge is negative, so that makes sense. It's going to go in the opposite direction, but the deflection would be 3 times less. So that makes perfect sense. What about the second particle? उसका क्या
Mass
होगा?
is 6 and the charge is -2.
And it's -2, right? So it's still -1/3, right? So that will also go in towards the positive side, and its deflection will be 3 times less. आखिरी का बनता है कि नहीं बनता? It's what do you get for the last one? So 1 and 2 are correct. Last one क्या बन रहा है? That's
Sir, +3 charge है और mass 9 है.
ठीक है, you're getting +1/3, right? That will not be true because if it's positively charged, it's got a positive charge, तो वो तो नीचे जाएगा, ठीक है? It's not going to go upwards. So that one is wrong. Third wrong है. ये question समझ आए?
Yes, sir.
So remember, इसके लिए बहुत क्या कहते हैं, for AS you have to practice a lot of questions, ठीक है? मतलब questions का level थोड़ा सा वो होगा, even बहुत basic, but I mean इसमें क्या है, proton, neutron, electrons, but it's even those questions are kind of very tricky. I guess you will be able to figure out this one on your own. ये वाला कर लेते हैं. I think this looks confusing. When nuclear reactions take place, the elements produced are different from the elements that reacted. ठीक है? So elements that reacted and elements that are produced. Nuclear equations such as the one below are used to represent the changes. The nuclear number total is constant at 236. As okay, the nucleon mass number total is constant at 236, and the proton number is constant at 92. In another reaction is reacted, and an isotope of a new element J is formed, as well as 2 neutrons. Okay. So what is isotope J? So he's saying this reaction, this reaction over here, that the nucleon number remains constant and the proton number total is also constant. And there's another reaction going on. So nucleon number and proton number is constant. So what I'm assuming is कि वो total की बात कर रहा है. What is the total over here? That's 238 plus 2. So the nucleon number is 240. 238 plus 2, that's 240, right? And the total proton number total is constant as well. So that's 92 plus 1, that's 93. Yeah. So दूसरी side पे भी यही होना चाहिए. You should have, but total at the end of the day, you should have 240 nucleon number and you should have 93 as the proton number. Remember, I'm just following this statement over here. ठीक है. So what is J then? 2 neutrons. So that means nucleon number में से क्या निकाल दें? We should remove 2 out of it. So J के ऊपर क्या होगा? You'll be left with 238. As a J, the top of J will be 238, and bottom पे क्या होगा? It's just going to be 93 because the neutron does not have any proton number, right? So the proton number total over here is 0, and over here, so the total should come out to be 93. So it's going to be 93. ठीक है, रिमेम्बर उसने क्वेश्चन में ये कहा था कि भाई जो टोटल whatever the total nucleon number is and the proton number total is constant. So if you have a total of 240 and 93 proton numbers over here, the total over here should also be the same. So I just figured out what J is, and J is 93. So how do you identify elements? You identify elements based on their proton number. So खोलो data booklet 93 पे देखो क्या आता है. 93 is 93 नीचे आ गया. 93 will be NP. It's Neptunium. That's NP. So I'll get a question. So it's going to be NP, and it's going to be NP with the nucleon number of 238. Is this question clear? Remember, this is a common sense question. There was nothing, no prior knowledge was needed for this. All you had to do was apply this. Is that clear?
Yes, sir.
Yes, sir.
So, or radioactive. Which statement about the phosphide ion and the chloride ion are correct? It's this is 15. This one is 17. They both have the same number of electrons, right? 18 and 18, right? They have the same number of neutrons, I think. Do they have 31 minus 15, 16, 35 minus 17? That's क्या होता है? 35 minus 17. That's, I don't think these two are correct.
18.
हाँ, वो different है. अच्छा, what else? वो कह रहे how many electrons? Hang हो गया, लोग जो. अच्छा, it's working. अच्छा, so now he's saying, okay, how many electrons are present in the hydrogen carbonate ion? Now, you should either remember it, or by looking at the formula, you should know that it's HCO3 with a charge of -1. So hydrogen atom has 1 electron, the carbon atom has a total of 6 electrons, and the oxygen atom has कितने होते हैं? 8 होते हैं. It's got 8 electrons and there are 3 oxygen atoms, so that's 8 into 3. So this is the total number of electrons, and it's got a -1 charge. That means the whole thing has 1 extra electron. So how much did you get? 24 plus 6, that's 30, 31, 32. So C is going to be your answer, okay? Or which species contains the smallest number of electrons? This one, I think. Helium-2 hota na, so it's got just 1 electron. Beryllium is 4, 2 electrons. Boron is 5, 3 plus, that's ठीक है. इसका कोई मुझे आंसर बताए, this one. Although this one is a simple question as well. Which ion, you're given 3 ions: hydroxide, OD -1, H3O +1, and D -1. Achha, D क्या है? D is an isotope of hydrogen. You got 2 isotopes of hydrogen. You got 1,1 and you got 2,1, right? Nucleon's different, right? Can somebody tell me which ion has both more electrons than protons and more protons than neutrons? क्या होगा इसका? अच्छा, अगर वो कह रहा है कि the ion has more electrons than protons, which one gets eliminated automatically? If the ion has more electrons than protons, what does that mean? कि उस
That something being said is not an atom.
नहीं, वो तो ठीक है. नहीं, that doesn't mean that. An atom can have, I mean, ठीक है, it's not an atom, right? What is it if it's got more electrons than protons? If something has more electrons than protons, is it a positive ion or is it a negative ion?
Negative ion.
Negative ion.
बस ये निकल गया, ठीक है, चला गया.
Positive.
नहीं, more electrons than protons is negative, ठीक है. तो positive वाला ये निकल गया, ठीक है. That's out of the question. And then he says it also has more protons than neutrons. So it's supposed to have more protons than neutrons, right? अच्छा, अब issue है कि the only way it can have more protons than neutrons is oxygen को देखो. You look at oxygen, it's got 8 protons and 8 electrons, 8 neutrons, right? 8 and 16. So So ये जो normal oxygen है ना, that's 8 protons and 8 neutrons, right? वो कह रहा है कि it's supposed to have more protons than neutrons. You can't have that with oxygen, right? Look at hydrogen over here. This D, ये जो deuterium है ना, D, it's got 1 proton and 1 electron. And look at the normal hydrogen. The normal hydrogen has 1 proton and 0 neutrons, right? So if you look at the three atoms that make up all of these ions, the only way you can have more protons than neutrons is कि उसके अंदर कौन सी चीज हो. ये दोनों होने का तो फायदा कोई नहीं है. You'll have the same number of protons and electron. बीच में क्यों लिख दिया? This is neutron, right? It's supposed to have H in it. ठीक है? It's supposed to have H in it. So the answer is going to be D. The only way you can have more protons than neutrons is if you have H in it. Is that clear?
जी सर.
Sir,
क्योंकि H के बगैर ना you can't have more protons than neutrons. O के पास equal number of protons and neutrons and D के पास equal number of protons and neutrons. So the whole thing will have equal number of protons and neutrons. D has equal number of protons and neutrons. So सिर्फ H के अंदर ना, so the molecule must have H in it. चलो इसी तरह का कोई ढूंढ ले और कोई ये तो आसान खुद ही करते रहो ये. इलेक्ट्रोनेगेटिविटी तो किया ही नहीं है. 1 second. अच्छा, so this question, I'll do this question although we haven't done mass spectroscopy, right? नहीं बल्कि छोड़ ही दो इसे, mass spectroscopy we haven't done that. This one is kind of, which of these diagrams are correct?
1 and 2.
ठीक है, 3 वैसे ही गलत है. ये सब भी atomic theory, John Dalton's, okay? It contains 4 predictions about atoms. Which of these predictions is still considered to be correct? Still, these are the 4 predictions. Atoms are very small in size. Which of these predictions still considered to be correct? I think the first one is correct. I mean, the first one looks correct. The second one is definitely wrong. Atoms, no atom can be split into similar parts. We've figured out we can split it into many simpler parts: protons, neutrons, electrons. Usko further split karo, leptons or quarks, or you can split it into smaller and smaller pieces. All the atoms of a particular element have the same mass. No, they don't have the same mass. You've got lots of isotopes. All the atoms of one element are different in mass from all the atoms of the other elements. No, 2 atoms can have the same mass. Okay. Proton number, sorry, 2 elements can have the same mass. Remember, the proton number is always fixed. How do you, ये चीज याद रखना, बहुत a lot of people get confused. Nitrogen जो element है ना, all nitrogen atoms will have 7 protons. That's the only thing that's fixed. Electrons can be lost and gained, neutrons can be added and they can be lost, right? So जो ऊपर mass होती है ना, that could be any number. Although nitrogen का जो stable isotope है, that's 14, right? But it could be 15, it could be 16, it could be, you could have, you can just Google nitrogen isotopes. मैं वैसे Google करूँगा. I just want to see के कितने ढेर isotopes ढूंढ चुके nitrogen के. So you can see के it's almost 25. Nitrogen having a mass of 25, you've found that one as well, right? 22, 21, 19, 17. सबसे ज़्यादा कौन सा है? The stable one, that's 14. 99.5% of all nitrogen atoms is the stable one. It's 14. 15 भी थोड़ा बहुत मिलता है, लेकिन 15 की जो percentage है, that's very less. That's like 0.3%, I think. So 15 थोड़ा कम ही मिलेगा, इतना ज़्यादा नहीं मिलेगा. So anyways, elements, remember, are identified by the proton number. Their mass could change, and 2 different elements can have the same mass. जिस तरह नाइट्रोजन का जो आइसोटोप है ना, 16, ऑक्सीजन की भी यही मास होती है. ऑक्सीजन का जो स्टेबल आइसोटोप है, that also has the same mass. That is also 16, but the proton numbers are different. So ठीक है, ये clear है question?
जी सर.
yes, sir.
एक सेकंड, पहला सब टॉपिक में एक सेकंड जल्दी से गो थ्रू कर लूं कि कोई ये तो उसी तरह का क्वेश्चन दोबारा रिपीट हो रहा है. contain the same number of electrons. You can just go and have a look. इसका definitely B C होगा. They all have 10 electrons. So बाकी simple ही होंगे. कल हम फिर ना ये कर लेते हैं this one just very quickly. What could be the composition of H3 plus 1, right? तो पहले तो H की क्या composition होती है? H is what is H? H is 1 1, right? So that means it's got one proton, it's got one electron, and it's got 0 neutrons, right? So that's what H is. तो इसमें 3 H है. इसका मतलब है कि there's going to be one proton, there's going to be another proton, and there's going to be another proton, right? अच्छा, neutrons सारों के पास 0 होंगे. 0 neutrons for the first H, 0 neutrons, 0 neutrons. Electrons, each one will have one electron, right? And since it's got a +1 charge, so that means one electron is lost. So it's going to have 3 protons and 2 electrons and no neutrons. ठीक है? चलो सही है, ये अब कल करते हैं, ठीक है? और अभी इसका मतलब इसमें सब टॉपिक्स हैं. We'll do the next one. This is just about proton, neutrons, electrons. This one. ये मैं भेज रहा हूँ, ठीक है, ग्रुप पे.
Okay, sir.
चल.
Okay, sir.
Okay. अल्लाह हाफिज.
Allah Hafiz.